Hello, ladies, gentlemen, and everything in between. This is your transformations review. Remember that we have covered 4 kinds of translation or transformations. Transformations is the category title, and then there are 4 subcategories of that. We have got translations, which is sliding left, right, up or down, and that's always going to be a plus or a minus to the x or y, as illustrated here. Now remember, if it's going left, it's going to be x minus, and if it's going down, it's going to be y minus. The reflections, it can reflect or flip over the x-axis or y-axis. If it flips over the x, remember that you change the sign of the y. If it reflects over the y, that means that you're going to be changing the signs of the x. Dilations are a stretch or a shrink, a reduction or an enlargement by a scale factor. Now this word right here, factor, tells you that it's always going to be multiplication. So right here we've got kx, comma, ky, aka if it is a whole number, it's going to be an enlargement. If it's like 2x, comma 2y, that means that the whole size of the whole shape has been doubled. If it's 1/2 x, 1/2 y, it'll be shrunk by, it'll be basically cut, the size is cut in half. So this could be a fraction. Just remember that. Okay, rotations. We can go 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees. So if it's 90 clockwise, you flip-flop your x and y. Well, first, you're going to take your x and make it negative. Then you're going to flip-flop your x and y. If it's counterclockwise, you're still going to flip-flop your x and y. However, this time you're making your original y negative. And then these flip-flop. If it's 180, remember that it's like, let's say it starts right here and it goes 90, 180. Well, up here it's positive, positive, and down here it's negative, negative. So both the x and y change the sign. Also, it works the same way. If you start here and go 90, 180 degrees, these negatives are still both going to go positive. So no matter what's in here, no matter which direction, no matter where it starts, the x and y will always change the sign. Also works if you start here and go 90, 180, it'll end up here. Those signs will both be flipped as well. So let's get into some practice. So this is the review that we did today, or if you're watching this in a different year, maybe we did not do it, but it'll still be good to review. So it says triangle RST has these coordinates. Draw the translation of RST 8 right and 4 down on your recording sheet. Now I didn't make a PowerPoint with the recording sheet on it because that's like too complex. So what we're going to do is just calculate it right here. If you of course did it by drawing, then it would be a lot easier, right? Because you take every point and you go 8 to the right and 4 down. 4 down tells it's a y, and 8 right, the right tells us it's an x. So the rule is going to be x to the right 8, aka plus 8, comma, 4 down, which is going to be y minus 4. So to find these new coordinates, it's real easy. I'll do it down here. R prime is going to be -2 plus 8, aka 6. 1 minus 4 is going to be -3. So that's our new coordinate for our new R. Goodness, sorry. I'm wondering. I just want to do this real quick. So that you can see it. All right, now S prime, ooh, I meant to go orange, but Oh well. S prime, you're going to take negative 8 plus 8 will be 0. That's a 0. And then 2, the new y coordinate will be 2 minus 4, it will be negative 2. Since I did it, might as well keep it going. Let's go green. T prime will be negative 4 plus 8, aka 4, and then negative 5 minus 4, 1. So here is the answer to that question. Next, it says quadrilateral HIJK has these coordinates. Draw the reflection over the x-axis on your recording sheet. So if you're doing this, it would be just flipped over the x. So it says there's 4. These are all positive, so it would be up here. If you're going to flip it over the x-axis, it would be down here. So remember, or maybe not remember, but just even look over here. Reflection right here, reflection over the x, aka this. This says all we have to do is change the y. So h prime will be 2 comma negative 3. I prime will be 3 comma negative 6. J prime will be 8 comma negative 6. And k prime will be 6 comma negative 2. So here are the answers. Oops. It only wants to know k. That would be the new coordinate for k. Remember, when you're flipping over the x-axis, you change the signs of the y. This one says rotation 90 clockwise. Rotation 90 clockwise, we're going to do this. So this time I'm going to look at the question before it's asked, and I'm just going to do coordinates of y. This one. So first this says change the sign of the x and then flip-flop. So y prime will be change the sign of the x and flip-flop. So now the x goes in the y position and the y stays the same, except that it goes in the x position. Rectangle EFGH has coordinates blah blah blah. Draw the dilation after it has been dilated by a factor of a third. So this k is going to be a third, so it's going to look like this. 1/3 x, comma 1/3 y would be the rule. And then the new coordinates of g, so g prime would be 3 times 1/3, which is the same thing as 3 divided by 3. Why is that the same thing? Because every regular number is secretly over 1, and when you're multiplying with fractions, you just go straight across. So 3 times 1, 3. 1 times 3, 3. Any number divided by itself? 1. So the new coordinate is going to be 1. This, negative 6. Negative 6 over 1 times 1/3 is negative 6 over 3, aka negative 2. That would be the new, that would be g prime, the new coordinate of g after the dilation of a third, aka a reduction or a shrink. And on to the next. Observe and record the coordinates of this transformation shown below. How can it be represented algebraically? Well, first of all, we've got to remember which one's the image and which one's the pre-image. So this one is the image, and this one is the pre-image. Remember the ones with the apostrophes? that's what happened after. That's the second one that happened. So the pre-image is there. Now, at first I'm going to ask myself, well, first I'm going to just know what I know. And what I know is that the triangles are the same size. So immediately this is cut out as an option. And also, the B is still on the top and the A and the C are still on the bottom. So nothing's been rotated, because if it rotates, it will change orientation, like it'll be facing a different way. So I know it's either a translation or a reflection. The way that I check between those, you could use your points to check, but I just use my eyes if I'm given a graph. So since A is on the left side, both, I know that nothing's been reflected, because if it gets reflected, the A would have to be on the other side. So it's not a reflection, so therefore it's a translation. Well, if we started in the pre-image, we're going to see how many we go over and how many we go up. So we went from -2, -2 over to, +2 to -5, which is 7 to the left, and then it went up 3. So left 7, up 3. So it says, how can this be shown algebraically? Well, x and then left is negative, and then y, and we went up 3, so it's +3. That would be the rule for that transformation. Alright, it says, observe and record the coordinates of this transformation shown below. How can this transformation be represented algebraically? Well, it's the same size, so cut out dilation. It pretty much looks like it's the same, it's facing the same way. So it's not a rotation. We just have translation and reflection again. Here's the thing though. Look, on the left side of the pre-image, the B was on the left. But here, on the other one, the B is on the right. And I can double check, because C is 2 away from the y-axis on the left, and then C is 2 away from the y-axis on the right. Therefore, we know that it's not going to be a translation, because number 1, the B is in the wrong spot, and number 2, it looks like a reflection, and also we've double checked it by making sure that it's equidistant from the axis. So it's a reflection. And just by looking, we know it's been reflected over the y-axis. Therefore, it's not that one, it's this one. So the answer is -x, y. When you flip over the y, you change the sign of the x. There are 12 cards total, by the way. Alright, observe and record the coordinates of this below. How can this be represented algebraically? Ooh. Okay, first of all, it's the same size, so I'm going to cut out dilation. It is not facing the same way, therefore I can't use translation. And if it's a reflection over the x, it would be, so remember that this is the pre-image. If it were reflection over the x, it would be up here. If it were a reflection over the y, it would be over here. But since it's none of those, can't be a reflection, it has to be a rotation. Here, if it went 90 degrees, it would end up here. If it went 90 degrees, it would end up here, counterclockwise. 90 degrees, it would end up here, clockwise. So it's not 90. So here's 90, 180. 180 degrees. And for 180, since it would be 180 going counterclockwise and 180 going clockwise, we can just say 180. How can it be represented algebraically? -x, y. AKA, whatever you had for x, change the sign. Whatever you had for y, change the sign. AKA, it transforms itself into the direct catty-cornered or opposite quadrant. Now if it started here and went 180, remember, it would just go down there. All right. Observe and record the coordinates of the transformation shown below. How can this transformation be represented algebraically? Well, remember, the one without the apostrophe is the pre-image. So we know that that one came first. So first of all, we know it's a reduction. So it can't be that, it can't be that, it can't be that, because look, it got smaller. Boom, that's it. Now, here's the thing that some people do find a little bit tricky still. You can do the dilation when you're given the rule. However, finding the rule, aka calculating the rule, is a little bit more difficult. But it's not really, it's just that people struggle with it a little bit. Let's just pick a, we will pick a point. I'm going to choose C because my name's Cassandra. So the pre-image C is 6, 4. And the image, woo, is 3, 2. So now we got to see what the heck happened to it. Well, we know it's a reduction, so if we get a whole number, we know we've done it wrong. I'm going to choose one of the points. Let's just choose X, might as well, and go 3 divided by 6. If you don't remember so to find the scale factor, it's you pick a coordinate of the image and divide it by the same coordinate of the pre-image. So we're going to do 3 divided by 6, and we get 1/2 is the scale factor. If you didn't remember that and you just wanted to try it out, I'm going to do that in blue. And you knew to check one, and you got 6 and 3, and you knew to use X on both, but you did this instead, 6 over 3. Well, that would give you 2. But you know, since that has the apostrophe, it has to come after. So you know, if the scale factor is a whole number like this, 2, it's got to be an enlargement, but it's not an enlargement. So, you know you're wrong. That's how you check yourself. I don't feel like I did a very good job of explaining that, but I hope that you got it. Come in with questions tomorrow if you have them, please. All right, rectangle JKLM was translated. Fill in the missing coordinates on your recording sheet and determine the type of translation that occurred. Well, I'm looking here at J. Nothing happened with the signs, so I can cross this out because look, you have to change the sign there, you have to change the sign there, change the sign, change both the signs. So those are both out. It's either a translation or a dilation. If there's a scale factor that's common, like 10 goes to 20 and 2 goes to 4, aka they were both multiplied by 2. Well, then that's probably a dilation. So let's see. How did 10 go to 3? Okay, minus 7. How did 4 go to 9? Okay, plus 5. So that's not the same, and it's not multiplication. Remember, this is always plus or minus. This is always multiplication. So therefore, this one's cut out as well. So the rule would be x minus 7, y plus 5. But they did not ask about the rule, did they? No, they asked us to fill in the missing coordinates. So I'm going to go here. We've got 10 minus 7, 3. 2 plus 5, 7. 6 minus 7, negative 1. 4 plus 5, 9. 6 minus 7, negative 1. 2 plus 5, 7. It says, and determine the type of That's funny. They already gave us. They said, I think that's a typo. They meant to write transformation. But it's a translation. It's a little heart. All right, 3 more cards, 2 more cards. No, 3. Triangle MNO was reflected. So here they tell us it's reflected. Oh, the type of reflection. Well, the type is either going to be over the X or over the Y, because they told us none of these. It's got to be one of these. And let's look. -5 changed to positive. -1 stayed the same. So they changed the X's. So here's they changed the X. They flipped it over the Y. So the rule is -X, Y. And it's a reflection over y-axis. So this will go 7, this will go 2, and then nothing will happen to the other coordinates. Home stretch. Quadrilateral PQRS was rotated. Boom, rotated. Fill out the missing coordinates on your recording sheet and then determine the type of rotation that occurred. So -5. Ooh, here's a -5. Well, we know we're not looking at this. We're looking at this. Okay, well they flip-flopped, so it's not going to be this one because here the X and Y are still in the same position, but they flip-flopped, so that ain't it. And then look, the -5 stayed, so the X coordinate did not change signs. However, here's a +7, here's a -7. The Y changed signs. Okay. The Y changed signs, and they flip-flopped. So it's a 90 degrees counterclockwise rotation. That's half your answer. The other half is going to be filling it in. So what I'm going to do is just write down all these X ones in the Y position because I know that nothing changes about them. Okay, so I got that. And then I just am going to change the sign of everything that comes, all of the Y's that come after that. Boom. And I'm done. Very last one. Triangle TUV was dilated. This is a really long video, by the way. 22 minutes and 57 seconds so far. Okay, it's dilated. Fill in the missing coordinates and determine the type of dilation. So dilation, the type. So AKA, is it going to be a shrink or is it going to be an expand? What's going on here? Ew. So 2 goes to 3 and 4 goes to 6. That looks like +1 and then +2. But the thing is, it's a dilation. Dilation is a scale factor. Factor says multiplication. So this is going to be nasty. So we're going to have to remember that the scale factor is the image divided by the pre-image. Right? Is that what I wrote on the previous one? I want to go back and check just a minute. Oh, I can't go backwards. That's cool. Well, we know it's an enlargement, so if we get a fraction, it's going to be a problem. So let's pick one. I like the 6 and 4 this time. Last time I used the X's. This time I used the Y's. It's okay. I think last time I said the image divided by the pre-image. So it's going to be 6 over 4. Well, that doesn't divide nicely, and when I normally say if it doesn't divide nicely, leave it as a fraction. But this time, we kind of need the decimal because we need the decimal in order to multiply it by these things. So I'm going to do in my calculator 6 divided by 4, and it's 1.5. So that's the scale factor. Okay, so then it's going to be 4 times 1.5, but Yeah, well, and I get 6, and 4 times 1.5, I get 6. 6 times 1.5 is 9, and 8 times 1.5 is 12. And then it says what kind, and it's an enlargement. You can say enlargement, you can say stretch, you can say it got bigger, it's whatever. All right. The very last thing that I want to say is you're going to have questions involving graphs, rules, aka these things. Given a rule, find the graph or the type. Given a graph, find the rule or the type or the coordinates. Given the coordinates, find the rule. So it can go in any of these directions. Given the coordinates, find the rule, or given the rule, find the graph, or given the graph, find the rule, or given the graph, find the coordinates, etc. So it's going to be on 1, 2, 3, 4 topics using combinations of 3 types of questions. So good luck! You're going to do great. Come in with questions, and that's it. Happy studying.